Hello students, we are solving the IB Math AA HL past papers and currently we are solving the IB Math AA HL May 2022 paper 2 time zone 2 past paper. Today we will be solving the last question, that is the question number 12 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS online math tutoring classes. So without any further delay, let us start answering question number 12. The maximum mark is 21. The population P of a particular species of marsupial on a small remote island can be modeled by the logistic differential equation dp dt equal to kp times 1 minus p over n, where t is the time measured in years and k and n are positive constants. The constant n represents the maximum population of this species of marsupial that the island can sustain indefinitely. Subpart A's question is, in the context of the population model, interpret the meaning of dp dt. That is the first derivative of p with respect to t. And what does this dp dt signify? It signifies the rate of change of the population with time. So that will be our answer. This will be the answer for our subpart A. dp dt gives us the rate of change of the population of marsupials with respect to time. Okay. Subpart B. Show that d2p by dt square, that is the second derivative of p with respect to t, is equal to k square p times 1 minus p over n times 1 minus 2p over n, where dp by dt, the first derivative, was equal to kp times 1 minus p over n, and k and p are positive constants. So in fact we have to differentiate this expression with respect to t. So let us start our answer for the subpart B from this point. It is d2p over dt square is equal to, now we are having two factors. This is kp and this is 1 minus p over n. So we will be using the product rule. Okay. So this is k times p is getting differentiated with respect to t. So it is dp dt. And this part is saying, and plus kp, and what is the derivative? The derivative of 1 is 0, it is a constant term, and the derivative of negative p over n will be equal to negative 1 over n times dp dt. Okay, and so I am seeing that k dp dt, this part is common to both the terms, so I can take this as the common factor. So this is k dp dt, and from this term we are having 1 minus p over n, and from here we are having minus p over n. Okay, so this is equal to k dp dt and 1 minus 2p over n. But we have not come to this given expression. How can we come to this given expression? We will be substituting the expression for dp dt from this part. Okay. So this should be equal to p, and in place of dp dt we will be writing this times kp 1 minus p over n, and then we are having 1 minus 2p over n. So which is equal to k square p 1 minus p over n and 1 minus 2p over n. Shown. Okay. Fine. We have completed answering the subparts B. Coming to subpart C. Hence show the population of marsupials will increase at its maximum rate when p equal to n over 2. Justify your answer. It is containing 5 marks. Okay, the previous question contained, subpart contained 4 marks. We have got that, those 4 marks. And now we come to the subpart C. It is containing 5 marks. Now the maximum rate of change of the population with respect to time, of course, is what? Rate of change of population with respect to time is dp/dt. So we want to know for what value of p are we having the maximum value of dp/dt. Just like we get the maximum and minimum points for f of x by getting the f dash x expression and equating it to 0. For those values of x, we get the stationary points for the graph of f of x. And whether that stationary point will be corresponding to a maximum or a minimum, or it will be a stationary point of inflection, we can find that out by getting the second derivative. Either we get the second derivative or we draw the sign diagram of the first derivative and check whether it is a maximum or a minimum or the stationary point of inflection. That is what we do. That is how we find the maximum and the minimum points. So, since we are interested not in the population but in the maximum increase, when is the rate of change of the population is maximum, then is the dp/dt maximum. Therefore, we have to, just like to get the f of x, maximum point of f of x, we take the first derivative. Over here, we want to get the maximum point of dp/dt, so we will be taking the second derivative and we will be equating it to 0. Okay. So, and we have got the second derivative expression. Let us equate it to 0. So, d2p by dt square is equal to k square p 1 times 1 minus p over n times 1 minus 2p over n is equal to 0. Okay, so let me just put this line. Implies, now k is a positive constant. K and n, they are positive constant. So k square will definitely not be equal to 0. So this implies either p is equal to 0, this, or 1 minus p over n is equal to 0, or 1 minus 2p over n is equal to 0. Right? So, can we take p equal to 0? Let us see. If we take p equal to 0, what happens to dp/dt? dp dt expression is containing p. So if p is equal to 0, dp dt is equal to 0. So we cannot take. dp dt equal to 0 means no change, means that when we are interested in getting the maximum rate of change. Over here, dp dt is becoming equal to 0, so we cannot take. So when p equal to 0, this is a capital P. I was about to write small p, it is capital P. dp dt is equal to 0. So cannot be taken, rejected. I don't have much space, but you can write hence rejected. When 1 minus p over n equal to 0, again the dp dt expression is containing 1 minus p over n. So dp dt is again equal to 0. Hence rejected. So the only other option that is remaining is 1 minus 2p over n equal to 0. Therefore, 1 minus 2p over n is equal to 0, which gives us 2p over n is equal to 1, or dividing both sides by n over 2, we get p is equal to n over 2. Okay? Not dividing, rather multiplying both sides by n over 2, we get p equal to n over 2. And now we have to check whether this p equal to n over 2 is corresponding to the maximum rate of change or the minimum rate of change, whether it is corresponding to the maximum point or the minimum point or the stationary point of inflection. We do not know anything. So we have to check. That is what is suggested by this. Justify your answer. Okay. Otherwise, just by doing this, they will not be giving us these 5 marks. So for this, what we can do one way is just like if in the case of f of x, you take the second derivative, we can go for the second derivative, but I don't want to go for the second derivative. Rather the third derivative, because the second derivative is already containing 3 factors. So I don't want to go for the third derivative. Let us let us take the help of the sign diagram. Okay. So what is the sign diagram? Let us take this sign diagram. Uh, it is the time, not the time, rather, it is the population. I have put this as a block in the dead end because p cannot be negative. So I'm not putting an arrow towards the left. And the n over 2 is the 0 point. And this one is the sign diagram of d2p by dt square. See, so I have to take one value of p from the left side of n over 2 and one value of p from the right side of n over 2. So left side of n over 2 will be having a value of p which will be less than n over 2. So let us take, say, n over 4. And this side, let us take 3n over 4. Okay. N over 2 is 0.5 m n. This one is 0.25 and this one is 0.75 m. Fine. Now, let us calculate. We will be getting the expression, we will be substituting n over 4 in the expression for d2p by dt square. That is this one. Okay. So, and we need only the sign. So, what we will be doing is, in place of p, I'll be writing n over 4. And k is a positive number, n is a positive number, so n over 4 has to be positive. And this is 1 minus 1 over n times p is n over 4. So this is cancelling and it is 1 minus 1 over 4, that is 3 over 4, again a positive part, positive number, and the third factor is 1 minus 2 over n times n over 4. And this is half. That means 1 minus half is half. So this is positive, this is positive, 1 minus 1 over 4 is 3 over 4. This is positive, 1 minus half is positive, half. So the product will be a positive number. Therefore, this is positive. What happens when p is equal to 3n over 4? K square times 3n over 4 times k is positive, so k square is positive, 3n over 4 is positive, 1 minus 1 over n times 3n over 4. That is 1 minus 3 over 4, which is 1 over 4, again positive, 1 minus 2 over n and 3n over 4. Now this one is 1 minus 3 over 2, which is negative half. 1 minus 1.5 is negative 0.5, negative half. So this is negative. This is positive, this is positive, this is positive, but this last factor is negative, hence the whole product is negative. So this is negative. Okay? And when you have the f dash x going from positive to negative, what type of stationary point do you have? A maximum point, because f dash x is positive means the graph, the f of x graph is rising, increasing. And when f dash x is negative, that means f of x, the f of x graph is decreasing. So when f dash x is changing from positive to negative, it corresponds to a maximum point. So this one is maximum. Therefore, p is equal to n over 2 corresponds to the maximum value of dp dt. So this is the justification, okay? And now this part is the answer for the subpart C. We come to the subpart D. Hence, determine the maximum value of dp by dt, that is the first derivative of p with respect to t in terms of k and n. And what is the expression for dp dt? It is kp times 1 minus p over n. Okay. So, dp dt, first of all, this is the subpart D. dp dt equal to kp times 1 minus p over n. Okay. So, it is equal to k times n over 2 and 1 minus 1 over n times n over 2. Okay. So, this is equal to k times n over 2 times 1 minus half is half, which is equal to k n over 4. So, this is the answer for the subpart D. Okay. Let T0 be the initial population of marsupials. Subpart E's question is, by solving the logistic differential equation, this is the logistic differential equation, show that its solution can be expressed in the form of kt equal to ln of p over p0 times n minus p0 over n minus p. Okay, so let us start our answer of the subpart E from this point. We'll be using the separation of variables technique. So I am writing this as dp over p times 1 minus p over n is equal to a dt. Okay. And you may keep this as it is, or else you may write this. Let me write this as dp over p times 1 minus, n minus p over n. Okay. So this is in fact equal to n over p times, you can keep it this way also. No problem. I have just used this method. I wanted to write it in this form, so I have written it in this form. Okay. So k dt. Then we will be just integrating both the sides. For the right side, obviously, it will be kt plus c. What about the left side? We are having two factors in the denominator, two linear factors in the denominator. So the obvious choice is to go for the partial fractions. So we have to first of all get the partial fractions. So therefore, it is n over p times n minus p. This should be equal to a over p plus b over n minus p. Okay. And then as we do the normal process, we will be multiplying the entire equation by the denominator, that is p times n minus p, to get n equal to a times n minus p plus b times p. Okay. So when p is equal to 0, n is equal to a times n, or p is equal to 1. Okay. And when p is equal to n, because when p is equal to 0, this part was equal to, this term was equal to 0. Now I am taking p equal to n so that this term, the first term, becomes equal to 0. Since we have already got the value of a, now we have to find the value of b. So when p is equal to n, we are having n equal to bn or b equal to 1. So we have got e equal to 1 and b equal to 1. So therefore, this n over p, I hope you are being able to see, n over p times n minus p can be written as, okay, this can be written as 1 over p plus b is also 1 over n minus p dp, which is equal to 1 over p when integrated with respect to p will obviously be giving us ln of p, and for this one it is ln of n minus p, but since you are having minus, so it will be And P is a positive number, so I am not in fact putting the absolute value notation. You can put the absolute value notation when you have the integration answer as ln. You have to put the absolute value notation, provided you do not know whether the number is positive or negative. We know P represents the population, which has to be positive. So therefore, I am not writing the absolute value. And this should be equal to the right hand side was equal to the integration of k dt. So this will be equal to kt plus c. Okay. And next, what do? We have to find the value of C. For that, we will be using this information. P0 is the initial population of the marsupials. Okay. And the initial population means the time when T is equal to 0. So therefore, when T is equal to 0, we are having ln of, and I can just combine these two. I can just write it over here because I have space problem. So this is in fact equal to ln of p over n minus p. Okay. Equal to kt plus c. So when t equal to 0, ln of p will be equal to p0. So it will be p0 over n minus p0 equal to k times 0 plus c. So c is in fact ln of p0 over n minus p0. Okay. So let us go back to this equation, and let us write this to be equal to ln of p over n minus p equal to kt plus ln of p0 over n minus p0. In place of c, I am writing this one. Okay, because we have found the value of c as ln of p0 over n minus p0. And now, since they have asked us to give the kt equal to make kt the subject, okay, so we can make kt the subject. Let me bring this to the side. Means I can write this as ln of p over n minus p minus ln of p0 over n minus p0 equal to kt. So again, I can combine these two terms, and I'll be having kt equal to ln of, this is p over n minus p divided by p0 over n minus p0 is multiplied by n minus p0 over p0. Okay. So this is in fact equal to kt is equal to ln of p over p0 times n minus p0 over n minus p. This is the expression that we were asked to show. Let me show you once more. Kt is equal to ln of p over p0 times n minus p0 over n minus p. You see, Kt equal to ln of p over p0 times n minus p0 over n minus p. Okay? So this is the solution, and we have got 7 marks. Okay, and after 10 years, the population of marsupials is p0, 3p0. After 10 years, p is equal to 3p0, and n is equal to 4p0. It is not after 10 years. It is known that n is the maximum population that the island can sustain. So n is equal to 4p0, and the population of the marsupials after 10 years is 3p0. So P is equal to 3P0 and N equal to 4P0. Subpart if's question is find the value of K for this population model. It is containing just 2 marks. Okay, fine. Just remember P is equal to 3P0 and N is equal to 4P0 and T is equal to 10. Okay. So I'll be using this. So this one is the subpart F. So it will be from here. I come to this point. It is K times 10 because T is equal to 10 years and ln of T was equal to 3P0 over P0. N was equal to 4P0 minus P0 over 4P0. T is equal to 3P0. Okay. So this is, therefore, K is equal to 1 over 10. And this P0 and this P0 will be getting cancelled. So it is ln of, okay, let us see, 3 times 4P0 minus P0 is 3P0. And 4P0 minus 3P0 is P0. These two will be getting cancelled and we have K value as 1 over 10 ln of 9. This is a paper 2 question. You can give your answer in some decimal number, but I prefer to keep it as in this form. Also, if you want ln of 9, you can write this as ln of 3 squares, which will be 2 times ln of 3, and you will be having 2 over 10 times ln of 3, and 2 over 10 can be written as 1 over 5. So these things can be done, but you do not have to do these, and you do not have to waste some more time on this question. And this is the last question, but even then, though it is in the last question, you have to check your answer. So it is better to keep it in this way. K is equal to 1 over 10 times ln of 9. So this is the final answer of the final subpart of the last question of this paper. And thank you for staying with me till the end. I'm Nilanjana Sanyan. I'm an online IB Math A, HL and SL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. And currently, I am solving these past paper questions from the AHL, of course, Math AHL section, and I am uploading these videos in my YouTube channel as you are watching. And in case you are liking my explanations, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching this video. And please do not forget to subscribe to my YouTube channel in case you have not subscribed till now. It will be motivating me if I feel that, if I find that you are liking my videos, I am being able to help you. So that will be a motivation for me. I'll be getting motivated and I will be making more math videos for you. Okay. And we meet again in our next session. We will be taking up the 2022 November paper, paper 1. So till then, bye.